Modern corporate mandates center on the elimination of the human error variable. This has led to the deployment of massive frameworks like AWS Greengrass and Azure Digital Twins, which attempt to automate industrial environments through sheer scale. These systems are architecturally device-centric. They process billions of data points, temperature, pressure, motion, yet remain incapable of interpreting the human intent or the organizational context behind those numbers. Building context-aware automation requires more than a software laboratory. It requires an operational logic developed in environments where data has immediate physical consequences. To manage a high-performance organization, an artificial intelligence must function as an integrated biological nervous system rather than a collection of disconnected software tools. Cian Kazi's approach to systems architecture began at age 15. Raising two brothers independently in a rural Illinois trailer park forced the development of a cognitive framework centered on resource optimization and rapid problem-solving. This resilience transitioned into land-based operations within the high-stakes motorcycle industry. As a general sales manager, Kazi set broken dealership records by treating sales as a series of tactical maneuvers and optimized workflows. He integrated aviation-grade situational awareness into his professional logic as a licensed private helicopter pilot. Flying requires a specific type of high-load cognitive processing, filtering complex instrument data to maintain a machine's equilibrium in real time. This drive toward high-level governance is a family legacy. In 1937, his great-grandfather, Qazi Abdur Rashid, was awarded the Khan Bahadur Medal, a title recognizing administrative leadership during the coronation of King George VI. His ancestral home, the Rose Garden Palace, provided the physical venue for nation building. It was at the family dining table that the Awami League was founded, the political organization that eventually secured independence for Bangladesh. This heritage of large-scale organization, combined with decades of tactical execution across land, air, and sea, informs the design philosophy of the Echelon AI control framework. The system is built to command an organization the same way an operator commands a complex, high-pressure environment. Echelon's operational scope is defined by the CWCSMRNN word corpus. This is a recurrent neural network, or RNN, which is a type of AI architecture designed to process sequential data by utilizing internal memory. The model is trained on a reality that includes technical units like 0 kilogram and specialized terms like acetylene. This ensures the network speaks the specific language of its industry. Training involves processing non-alphanumeric patterns and symbol sequences. By learning repeated fragments, the system recognizes structural delimiters and breaks in complex real-world data flows. The creator's own identity is embedded into the network's primary recognition layer. Names like Cyan and Kazi act as semantic anchors within the corpus, linking the model's vocabulary directly to the architect's intent. Digitizing these human and technical variables allows the AI to recognize the operational intent behind a stream of data, rather than just identifying individual words. Academic reviews place the Echelon architecture in the research grade tier. Its technical markers match systems found in university labs and EU-funded initiatives, rather than consumer products. At the hardware edge, the system utilizes sub-6 GHz MIMO antennas, using spatial multiplexing to handle higher data throughput and lower latency than standard IoT protocols. The architecture then bifurcates into the CPH managing user identities and the CCH brokering environmental data. While commercial platforms like AWS and Samsung SmartThings are built to manage device states, Echelon's design is capable of fusing social network data directly with physical sensor inputs. Most enterprise platforms rely on device shadows, virtual representations of a hardware state. Echelon replaces this device-centric view with human-centric situational awareness. Echelon provides a level of cognitive reasoning by mirroring biological context synthesis, the same way a human brain aggregates sensory data into a single, actionable reality. High-stakes execution often fails due to a limbic hijack. This occurs when emotional stress triggers the brain's fight-or-flight response, effectively locking the rational pilot out of the corporate decision-making cockpit. To solve this, the system employs a framework of co-regulation. This is a biological principle where a calm, structured presence, biologically soothes and stabilizes an agitated environment. Echelon's biodigital performance protocols translate this emotional intelligence into automated operational intent, acting as a stabilizing anchor for the organization. The AI super assistant defines the system's executive persona. It applies assertive compassion, setting firm boundaries and maintaining structural integrity even in chaotic scenarios. The Echelon standard is a proprietary digital nervous system built for organizations that demand aviation-grade situational awareness and the systematic elimination of human error.